All right, in this next video, we're going to learn how to apply concentration to unit conversions and stoichiometry. So let's start out with a simple statement here, and that is that molarity, and if you remember, molarity was moles of solute per liters of solution, can be used as a unit conversion. And stoichiometry. All right, and let's go ahead and take a look at a practice problem here. And I'm just going to give us an equation, and we're going to start out by mixing sodium hydroxide, that's aqueous, with acetic acid, this is just vinegar. And again, it's going to be aqueous. And because we're mixing a base, sodium hydroxide, with an acid, vinegar, we're going to create water, which is a liquid. And we're going to create a new ion pair. So we're going to now have this acetate ion paired with the sodium cation, and this will be aqueous. All right, so this is the example equation we're going to use for a bunch of practice unit conversions. Okay, so let's start off with one example. So the first example is what volume of 0.125 molar NaOH contains 0.255 moles of NaOH. Okay, so let's kind of break this down a little bit. It says that we've got 0.125 molar sodium hydroxide. So what does this mean? Well, it means that for 1 liter of solution, that we have 0.125 moles of NaOH, right? So this can be applied as a unit conversion. So let's go ahead and set up the math here. So it's asking what volume contains 0.255 moles. So we know we've got 0.255 moles that we're considering. And now we need to cancel out moles of NaOH, and we need to figure out our volume of solution. So what I would do is do liters of solution on top. Okay, we know we can cancel out moles this way and be left with liters of solution, but then up here we know that 0.125 is paired with the moles. So I'd say 0.125 moles of sodium hydroxide are in 1 liter of solution. By doing this, we cancel out moles of sodium hydroxide, and we can solve for liters of solution. If I go ahead and type this into my calculator, I'm going to get 2.04 liters. So as you can see, we were able to apply a unit conversion simply based on this molarity unit that was given in the problem. Okay, let's try a few others just to keep on practicing. Okay, in this next one, it says what volume of 1.25 molar sodium hydroxide solution contains, oops, sorry, I was repeating here, is needed to react with, let me check my notes here, 0.0755 moles of acetic acid. Okay, so same sort of idea here. We've got a unit conversion through this, right? So we, just like before, we could say that 1 liter of solution contains 0.125 moles of NaOH. Okay, so now let's try to plug numbers into this one. So we know we're trying to figure out the amount needed to react with 0.0755 moles of acetic acid. The problem is we don't have moles of acetic acid right here, and that's what we need to cancel out. Okay, so let's try to set this up, and we'll say moles of CH3COOH on bottom, and then let's convert to moles of sodium hydroxide because that's a unit we know how to work with. Okay, so then the question is, well, what's the mole-to-mole ratio here? Well, let's go back up to our equation. If we think about it, right, we've got 1 mole here plus 1 mole here going to 1 mole of water and 1 mole of our other byproduct. So really, we've got a 1-to-1 ratio here. It seems silly to have to put this in, but it's still good practice, especially for situations where it's not a 1-to-1 ratio. And let's just slide this over. So now by doing this, we've canceled out moles of acetic acid and we've got moles of sodium hydroxide. But now we need to cancel out moles of sodium hydroxide, so I'll put that on bottom. And we're trying to figure out the volume of sodium hydroxide needed, so I'll put liters of solution up here. And just like before, we know 0.125 is paired with the moles of sodium hydroxide, so I put that on the bottom. Oops. So 0.125 moles for every 1 liter of solution. So now we cancel out moles of sodium hydroxide, and we're left with liters of solution. And if we go ahead and put this into our calculator, I'm getting 0.604 liters of solution. So that would be the correct answer for this one. But like I said, this part right here became a really important unit conversion in this math problem. Okay, let's try one last one and then we'll call it good for this video. So in this last one, it's going to get a little bit more complicated. But in this last one, it says, what volume of 0.125 molar NaOH, our sodium hydroxide, is needed to react with 154 milliliters of 0.840 molar acetic acid. I actually looked this up. Acetic acid is just vinegar that you would buy at the store. This is the actual molarity of most vinegar that you would buy at the store. So that's why it's kind of a random number there. So again, we could look at this and we could say this tells us that in 1 liter of solution that there's 0.125 molar NaOH. Okay, and then over here, this is our second unit conversion that we'll use this time. And this time it's saying that in 1 liter of this solution that we have 0.840 moles of our acetic acid. So we've got 2 different concentration conversions we might need to use. All right, so let's start out with what we have. We've got this value here, 154 milliliters. So I'd say we've got 154 milliliters of CH3COOH solution. And we need to cancel out our milliliters and get to liters, right? Because over here, we're dealing with liters of solution, not milliliters, okay? So down here, I'd say, well, 1 milliliter is equal to 10 to the negative 3 liters. So we can go ahead and cancel that out, and now we've got liters of solution. And now we can say, well, 1 liter of CH3COOH solution has 0.840 moles, right? Okay, so now we've gone ahead and we've canceled out liters of solution, and we're left with moles of our acetic acid. So we're partway there. Sorry, I'm going to slide this over just so we have more room to work with. And now we could say, well, we know from the previous problem that for every 1 mole of our acetic acid, we need 1 mole of sodium hydroxide. And you might be wondering, well, where did we get this from? If you remember, we got that from these ones up here. So that's the coefficients for these problems. It's a 1-to-1 ratio. Okay, so now we've canceled out our moles of acetic acid, which is good. So we've got moles of sodium hydroxide. But it's actually asking us what volume of sodium hydroxide, not how many moles do we need. But that's okay because we've got the molarity that says, well, if we have, whoops, this should have been mole, not M. That if we know how many moles we have, we should be able to figure out how many liters we have as well. Okay, so down here we could say that there are 0.125 moles of NaOH and 1 liter of solution. By doing this, we can cancel out moles of NaOH, and we'd be left with liters of solution. Okay, I'm just going to put this down here. And if you go ahead and calculate all of this, you should be able to get an answer that is 1.03 liters, right? And as you can tell, this took a fair amount of work to accomplish this transformation. However, there's a trick from our last video where we said M1 V1 equals M2 V2. And M is molarity, and V is volume. Okay, so let's think about it this way. Let's set M1 and V1 to be the molarity and volume for sodium hydroxide. We're trying to find the volume, right? So we could say, well, V1 is going to be equal to M2 V2 divided by M1. And the molarity of our second component that we were dealing with, meaning not the sodium hydroxide, was the acetic acid, and we said that that was 0.840 molar. And we said that we had 154 milliliters of that acetic acid solution. And if we divide that by the molarity of our sodium hydroxide, it was 0.125 molar. If we do this, molarity will cancel out. We'll be left with milliliters. And this will be 1.03 times 10 to the third milliliters of solution, which if you think about this, these are actually the same thing. So if you want to use this trick, you can. You just have to have the molarity and volume of one of your components, and at least the molarity or the volume of your second component, meaning you need 3 of the 4 variables to solve for the 4th. So it's a good way of kind of trimming down the amount of work. But this is kind of a neat way of seeing how you can do this long way to get your answer, or you can do this shorter trick way to get the answer. I don't really have a strong preference. If you prefer one over the other, you're welcome to do it the way you're most comfortable with. All right, I hope that helps.